Hello.
Hi, we're going to do some of the capacitance webassign problem set. We'll probably have to break this up into 2, maybe even 3 portions, but we'll start off with some of the easier ones. We'll do them all, actually. Number 1. They give you some charge. They give you both a plus and a minus, and we don't care about the sign. It's just the amount of charge that sort of gets moved. And they give us a voltage. So, capacitance is charge per voltage. So they do give us the charges in PC, which is not politically correct, but it's picocoulombs. So we could convert them if you want, and we could get a capacitance in farads. But if you look at the answer for letter A, they want it in picofarads. So we really don't even need to convert. We can just leave that in there. And I'll let you do the math. That's not super tough. Letter B, the same thing. They're saying they want to know what the capacitance is, but now they're saying we've changed the charge. Well, if you look at our equation to describe capacitance, then you'll notice that nowhere in there does it mention charge. Yes, if we change this, we'll also be changing that, but overall the capacitance doesn't change. So whatever you got for letter A, that's actually going to be your answer for letter B. Now for letter C, they're sort of hinting at, well, this is going to change and this stays the same, well, this will change too. And you can still, once again, use the exact same thing for letter C to just get a new voltage. You'll have a new charge there, the same capacitance, and get a new voltage. Okay, for number 1? Any questions? No, I didn't hear any questions. Okay. Maybe I should have left those equations up there because we will use them on occasion. Like for number 2, they give us a certain size capacitor, and it is in microfarads. And they give us a certain voltage, and they just want to find how much charge will pass through it. So if we do that, we'll get an amount of charge, and they do want it in coulombs, so this time you do need to convert some units. That's all there is to for that particular one. Number 3, they're asking you to find the separation between the plates. They're going to say or pretend that we do indeed have a parallel plate capacitor. Oops. Something like that. And so they want to find the distance between these. And they give you area, check. Well, they give you the capacitance. We know the constant. And I don't think it says, so we're just going to assume that the K is just 1. There's nothing in between them. So we can do a little bit of rearranging. We can solve for our D, and then we can even make a little comment as to the distance that we got with the little 3 multiple choice thing. Number 4. And number 4 is when we get into adding capacitors, more than one of them in some arrangement together. We can add them in series or we can add them in parallel. If you've got them in series, like those two, then strangely enough, these two connected together end up making less capacitance overall. If you've got them in parallel, like that, that ends up adding together their capacitances, or making the capacitance greater that way. If you've got this, then all you have to do is add them together, for however many ones you have in parallel. If you've got this, the capacitance gets less, and you're not subtracting them though. You can use this funny looking reciprocal equation here, or hopefully, like I may have told you in class, use the shortcut. The shortcut is simply the product of the two divided by the sum of the two. And that's actually pretty easy to do. Sometimes if you've got nice round numbers, you can even do this in your head. So that is what we're going to do for the C1 and C2. However, then once we get that combination, it will then be in parallel with the other one, C3, and you can just add them together. So that's how you do that, number 4. And I think maybe we'll just verbally address number 5 here. Won't even write in number 5. But number 5, once again, has a combination of sum in parallel, sum in series. So if you look at number 5, you will see that C1 and C2 are in parallel with each other. They don't look like this picture, but still it's a path where some charge can flow through each one. They're basically two separate paths for C1 and C2. However, once you get those two added up, that one is also, or it is in series with C3. So once you do this for C1 and 2, you got to do this for that combination and C3. Okay, we will stop there, and we'll come back and we'll do probably 6, 7, 8 or something like that.